Hello everyone, my name is Natalie Parker. Today I will be going through a walkthrough of example 2 for ZDPlasKin. If you need any help with specific components or you're new to my videos, I suggest taking a look at my previous videos on installation, understanding ZDPlasKin, and going over the first example. Before we get started today, I have a couple of acknowledgments. I want to thank the National Science Foundation and the University of Nebraska-Lincoln for providing me and funding my research as well as giving me an opportunity despite the coronavirus pandemic. I would also like to thank Dr. Barry Chung and Deepa Chouardi for their mentorship in this program. My goals today are to run, download, and complete example 2. We'll take a look at all of our components, and for this case we are working with more than one module. We are also going to analyze and plot our data. To download example 2, go to the ZDPlasKin website. I've linked it in the description. I'm going to do the example titled Microcathode Sustained Discharge in Argon. You can read through this test and download the zip file. So, what are we testing in this case? Well, based off example 1, we only had 2 reactions, and we could complete it. So now we can add some more species. In this case, we are using both gas phase species and the surface absorbed species. In the next slide, I have shown the section in the connect.inp. We have all of our species, reactions, and conditions in this file, which we haven't seen before. This is because we have an additional module, the master module. We have more conditions that are not constant, so we need to specify for that. Let's take a look at our zip file. Once you've extracted it and opened this file, this is what you're going to see. First is that Mac file. If you were using a Mac, it'd be super nice, but I'm using Windows, so it's irrelevant to me. Next is the AR2 React. This is our output text. They have given it to us to check our work after the test. Third is that database, the bolsigdb.dat, and then fourth, the bolsigdb.log shows all the reactions that were used in the database. The conditions INI file lists things such as gap length, pressure, and voltage, and in this case, we have these, in the last case, we had these written in our code, but we have a lot more non-constant conditions, and so they're distributed into a few different parts. Number 6 is our connect.inp. I showed this guy in the last slide. The master code is our main user code. This has all of our initial densities and subroutines. This code uses the conditions INI data. Then we have the master module, which has even more conditions. And then finally, that leads us to our ZDPlasKin module. This means that the connect.inp has already been pre-processed, and that's something that we don't have to do in this case. Next, there's a few things that we need to add to our file in order to run our code. For the ZDPlasKin extracted file, we need to add in the preprocessor, the bolsig_g.dll, the bolsig_g.lib, and the devode_f90_m.f90. Additionally, we need to add in our QTPlaskin line to the software so it knows where to put the QTPlaskin files. I put this inside the mastercode.f90. Once you've figured it all out and you have everything in one place, we can run it. So you'll want to go into the folder and type the following: gfortran-o ex2.exe, or whatever you want to name it, devode_f90_m.f90, master module.f90, ZDPlasKin, the module, the mastercode.f90, and the bolsig_g.dll. It will give you an output named ex2.exe, or whatever you named it, in your file. So to open that, just type ex2.exe and enter. It'll release a bunch of text files that are your QTPlaskin results. So here's a quick visual of the code itself and how I ran it. In this case, you're just going to want to put everything in that particular order. So moving on to my QTPlaskin results, you'll just want to go and open the program, go to File, and Import from Directory. The graph on the left shows a few of the gas phase argon species, while the graph on the right shows all of these surface absorbed species. From our results, we can see that we are working with more species, and from those species, we are seeing some different patterns. Some appear linear, while others are being created quickly and then leveling off. The most important part is looking at our conditions. We are working with so many conditions that are non-constants. If you want to go into your overview and look through the different conditions, it'll make more sense that throughout the test, more and more of our species are being produced. This test was super important as it shows the significance of conditions. We can set them as constants, but what happens if they're almost all non-constants? That'll reflect in our results. I want to thank you guys for joining me today, and I hope this cleared up something for you. If you have any errors or problems, you're welcome to email me personally at natdparker22@gmail.com or join our Google group. Both are linked in the description. Thank you for watching!